We'll start with 3 Kubernetes clusters. One of them will be the management cluster that will use this KM alias to access it. And as you can see, there's nothing really deployed here apart from MetalLB that we'll use to expose some services externally. And the other 2 clusters are called the workload clusters, and we'll use K1 and K2 aliases to access them. Again, nothing's deployed on here. So let's start by downloading the Meshcuttle CLI. And we can use this CLI to deploy various Gloo components directly to our clusters. But in this lab, we'll use Helm to deploy everything declaratively. And we'll use the Meshcuttle CLI just to check the registration and the health of the workload cluster and the management cluster. So we downloaded the latest version, and we'll use Helm to deploy the management plane. So there's 2 Helm charts, one for the CRDs and one for the management plane components itself. And as you can see in these options, there's really nothing special here. We mainly just want to say that we want to use the service type load balancer because we're using MetalLB. And now let's give it a few seconds for everything to be deployed. Once that's ready, we'll need to set some environment variables that will be used so we can tell the agents in the workload clusters how to communicate to the management cluster. So these variables will be used for the installation of the components, the agent in the workload clusters. So if we look at the diagram, you'll see that the workload clusters on the bottom have these agents which are going to initiate a connection to the management cluster. And you can see it's like one direction. So the management server doesn't know about how to reach the workload clusters. It's always the agents that are initiating the connection. So let's register these agents. There are some security mechanisms in place to prevent someone from registering other clusters to the management plane without permission. First, the platform team needs to create a Kubernetes cluster object in the management plane for the cluster that needs to be registered. And then when you were ready to register that cluster, you would need this rotatable token, which will be used by the agent to initiate the connection the first time to the management server, and then it'll get a certificate and it'll do proper MTLS moving forward. Many of the options we set here are just telling the agent how to communicate with the management server, and the telemetry gateway, which is an open telemetry collector that's running in the management plane that's going to collect the metrics from all the various workload clusters. So we do that for the first cluster, then run the same command for the second cluster. Give that a second, and then we can check to see what are the different components that were deployed. So on the management server, we have the 2 like the management server pods, and we have the UI that's using Redis for caching, and a Prometheus server to access the metrics that have been collected through the open telemetry collector called the telemetry gateway. And then on the workload clusters, you'll see the Gloo Mesh agent that's reaching out to the Gloo Mesh management server. And we also see a Gloo Mesh telemetry collector, which is another open telemetry collector that's going to capture and collect all the metrics from the local cluster. And this is a daemon set, but we only have one node here. So, and then this pod will then send these metrics to the telemetry gateway on the management cluster. So now we can use Meshcuttle to check the connectivity and the health of the different workload clusters. We can see all kinds of information about the licensing. We can see the various components that are deployed on the management cluster. We can see that they're healthy. We can see the agents that are connected and registered. And we can also see which pod that they're connected to on the management server. And this is important because we can scale the deployment on the management server to multiple pods. And this allows us to spread the connections of different workload clusters, allowing us to scale to dozens or even hundreds of workload clusters connected to a single management plane. We can also take a look at the Gloo Platform dashboard, the UI. So we'll get the IP of the UI and then access it in my browser. And I can see the two clusters that are registered, the workload clusters. Right now I can just see the version of the Kubernetes, but Istio is not deployed yet, so we don't have any information about that yet. And I also don't have any workspaces because I don't have any workspaces created yet. Gloo will actually emit metrics about the agents that are connected to the management plane. So to do that, we can look at the Prometheus metrics that are exposed on the /metrics endpoint on the management server pod. So this allows us to create alerts, for example, if a workload cluster becomes disconnected. So in this case, the metrics are showing that we have two clusters connected because each one of them have a value of 1, and you can see the cluster name. Finally, we're going to create this workspace settings object, which we'll cover in greater detail in a different video. But essentially, this object, this global workspace settings object, allows platform teams to configure options that they want to enforce for all workspaces. In this example, we'll create this object to specify which Istio gateway that we want to use for east-west or cross-cluster traffic. We haven't deployed Istio or this gateway yet, but we'll do that, and we'll do that later.